freaking got me back to looking at this stuff. I haven't looked at this stuff since 2013, about 10 years ago. And anyways, I'm just going to show you the process that I know. It's the one that I remembered, the one I have experience with as far as stitching photos together. Of course, it's made for 3D stuff, but I mean, it can do 2D. By 2D, I mean like you can take whatever mesh you get and flatten it out into 2D if you need to. But it's a very generic workflow that works for any type of photography. It's this thing called Visual SFM, the structure from motion. A lot of white papers about it. A lot of hubbub came up about it 2012, 2013. If you remember, that's when like the Google Maps 3D shit got really good, or rather started to improve. So it's been forever since I've gotten this stuff, and unfortunately, a lot of these binaries, a lot of this stuff has been monetized. So it was previously released like under these white papers, kind of like under different licenses, but now it's been monetized. Like if you click on this, it's gone. If you click on this, gone. These are different binaries that you need. So like this is kind of like your visual GUI, and those are kind of like command line tools, but you still need them. And all that stuff's kind of been relocated. But I wound up finding some copies of them online. So yeah, you can ignore all that. It's a bunch of junk. I got this test set right here, which is of this. This is just a desk ornament. Someone walking around. Just walking around this model here, and I got it loaded up. And so this is kind of the kind of pictures I need. As far as like from one picture to the next, there's a lot of overlap. And what it does, it goes down through here, and it will detect features. Like it'll detect this horn here is the same horn here, is the same horn here, etc., etc. And it'll use that to work out the camera's position through what's called bundling adjustments. With GPS coordinates in your images, it'll be a constrained bundle adjustment, which means it'll run much faster, but that really actually doesn't take all that long. Feature matching takes, a few minutes. Should go to show feature. Wait. Oh, that resets coordinates. That's not what I want to do. Yeah. So it's all the different features that it matches. So it does all sorts of stuff, but it does all this stuff automatically. The workflow is pretty basic. What you do is you just open this folder. In the beginning, it just had images, and it'll create other types of stuff in here. But it'll just have images. You open the folder. You will see what is image sound now? Yeah. It starts off like this, and you just click. Once it's all set up, you just click this button up here, this one, match features. It'll compute the missing matches, and then you'll get all those lines going across through there, but then you'll click the sparse reconstruction, which then brings you, once that's completed, to your in-view 3D points here. And this kind of shows so this shows the perspective of how where the camera was in relation to the object, and also kind of how it was oriented. Now this image set has a bunch of wacky angles where he's rolling the camera left and right, because it is arbitrary. But on a drone, all of these would be kind of level, like with the horizon, I guess. And so you can see how You know, he's moving around through here from point to point to point to point. You know, kind of slowly, you know, snap, 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 snap. But you run that, you get this, which it's a little sparse. And you can get this pretty quickly. I mean, you can run this within, you know, 3-5 minutes maybe. This was 50 photographs. And then you can, then you run the dense reconstruction. And that takes like 10-12 minutes. You know, it takes a little while. And then you wind up with your dense points. And so that's not bad at all. And what way he's facing? Oh, he says that's my bad side right there. That's the bad side, so I can't really see it. But anyways, and this is a complicated object with, you know, it's a, you know, where you gotta walk around it and all sorts of stuff. But from the perspective of a drone, you are going to get shadowing effects always. So, but that comes down to your photography. You know, like you just didn't have the photo coverage there. And then you could do it partially. So you could do this part. You could add more images, match those, and do a, you know, a partial, you know, and partially like fill in these spaces. But ultimately, you're going to take this point cloud, and you are going to go through the workflow, which, yeah, you do all that. See how they kind of like you walk around a structure or something, and then you take it into Mesh Lab. Where's it at? Or did I pass it? Yeah. You take it into Mesh Lab, and then you can basically convert these points, because these are just a bunch of fine points, thousands and thousands of points with RGB information. And actually, because if your photos are geolocated, you should be able to get like a latitude, longitude, and altitude for each one of these, in theory. So you can make measurements from it, and that's one of the good things about photography, is it's pretty accurate with measurements. But you take this point cloud, and you can directly get shit out of it with Cloud Compare. So like if you just wanted to measure like the highest point of a terrain or something, but you can take it into Mesh Lab, turn it into a mesh, and then kind of filter it and clean it up with various tools. Of course, there's some spurious output here, you know, you gotta, and I mean, you can select. How do you select? I have no idea. Anyway, I'll figure that out later. But you clean it up with that, run it through the mesh thing, and then you can wind up with a pretty good looking situation. It is 3D. I know that's not what you're looking for necessarily, but this is the only way I know how to do it. And it works okay. It's not difficult. Like I promise you. Like you just open a folder. Like I browsed into that image folder. I said Control A to open all the images, and then I click one button. Shit, I think where it was. I click this button. I click this button, and then it shows me this 3D image once it's done. But hell, I'll just do it again. I mean, hell, we'll just watch it. Go, baby, go. So you see how it's kind of marching around. See, these images, they don't have any kind of they don't have GPS or anything. It's just using feature matching and the assumption that the subject is static, like it's not moving, like you don't have people moving around in it, you know. So it can treat every image kind of like an extra eye, you know, for like stereographic vision. And that's one of the issues with this method is like as the sun moves around, as the clouds come over, it really changes the way this shit looks. See, like that took 50 seconds for it to figure out. I mean, this is after you've feature matched. It takes about 50 seconds for it to figure out, okay, that's where the cameras were. And then because you have geotagged images, there's no compass. That's where I was kind of hesitant. So you'd have to do there's some tool to do a geographic, like, yeah, there's some tool in here that will let you do a geographic translation. So you just have to manually enter the compass heading. And then essentially each point can be converted to GPS coordinates. It's pretty powerful.